4.7 transformation of quadratic graphs. So let's go through this worksheet. So we want to put it in vertex form, which is y equals a x minus h squared plus k. Right, remember when you do this, your vertex is h and k. So here we got to find, let's find a vertex like we did in the beginning of the chapter. So the way to find the x in vertex is axis symmetry. So we're going to find x equals negative b over 2a. Just like when we do quadratic formula, a is 1 here, b is 4, and c would be 6. So a would equal negative 4 over 2 times 1, negative 4 over 2, which equals negative 2. Now you got to find the y value in the vertex. So the way you do that is to plug that into the equation. Y equals negative 2 squared, there we go, negative 2 squared plus 4 times negative 2 plus 6. And that would get us 4 plus negative 8 plus 6, which would get us 10 minus 8, so 2. So our vertex is negative 2 and 2. So if I want to put into this type of equation there, so let's write it right here. Now that I have all the information, all I gotta do is this. My vertex is negative 2 and 2, that's h and k. So that goes here and that goes here. How about my a? Well, the exact same a we have up there, 1. So there's my equation. Y equals 1, which I don't need to put. X plus 2 because double negative, squared plus 2. And there we go. Now let's do the same thing for this one here. So let's find the vertex first. So if I was going to find the vertex, we're going to do x equals negative b over 2a. So negative negative 12 over 2 times 2. So 12 over 4, which is 3. That's the x in vertex. If I want to find the y, I just got to sub it in. So y would equal 2 times 3 squared minus 12 times 3 plus 17. This is 9. 9 times 2 is 18 minus 36 plus 17. That's going to be negative 1 because 18 plus 18 would be 36, but that's 1 less, so 35 minus 1, negative 1. So my vertex is 3 and negative 1. So we're going to plug it into this formula here. And now we know what everything is, h and k, and my a is right there. So 2, 3, negative 1. So y equals 2, x minus 3 squared plus minus 1. And there we go. So that's, to me, that's the easiest way to put in vertex form. You don't have to do it that way though. The other way you could do it is by completing the square. So I'm gonna do this one by completing the square. Oh, it's one. Okay, well, I'll do this one. Yeah, I'll do this one by completing the square. Okay. So if I want to complete the square, I can add the 1 over. So we y plus 1 equals negative x squared minus 4x. The reason I was hesitating is because I have a negative 1 there. I can't have that when it's a square, so I have to factor it out. So negative 1 x squared plus 4x. And when you factor, you're just dividing. So if you want to complete the square, you can't have a number in front. The coefficient of x squared has to be 1. So I get this, and I can complete the square. So we're going to get the middle term, divided by 2 and square it. So 2 squared is 4, so plus 4 here. If I added 4 to this side, remember, you're adding 4, but it's going to multiply by the number outside, so you're adding a negative 4 actually. So I get y minus 3 on this side. Over here, it's a negative 1. Factor all this. Remember, it's the thing before you square it. So x plus 2 squared. So we have this. Let me write that a little nicer because that's a little sloppy. A little better, I can see it. And then you just want to get the y by itself, so add 3 to both sides. And that's in vertex form. So both ways work. Either way is fine. If you prefer complete the square, you could do by complete the square. Or you could do by find the vertex. I honestly personally mostly do by finding the vertex. Like I do right here for this one. So I'm going to find the vertex here. I know my A is, I know my B is, I know my C is. I'm going to find the vertex. X equals negative B over 2A. So negative 8 over 2 times negative 2. So negative 8 over negative 4, or just 2. So that's the x my vertex. So find the y, you sub it in. That's a 4. So I get negative 8 plus 16 minus 5. Negative 8 plus 16 is just 8, minus 5 is 3. So my vertex is 2 and 3. So I'm putting into the formula. Right, my vertex is 2 and 3, and my a is the exact same as this guy up there, so negative 2. So y equals negative 2, x minus 2 squared plus 3. That's it in vertex form. Let's move on. Write an equation in vertex form for each parabola. So again, we want to write this. In this case, we have the equation. So there's some good news and some bad news. The good news is you already have the vertex. Hey, right there, h and k, right? That's a vertex. So I already know what h and k are. So if I was to write this equation, I know what two of them are. This is negative 4, and that's 3. What I don't have is my a. So unlike the last time where I had a was by far the easiest, this time I don't have the a. But I do have another point, and what that is, we're going to make that your x and y to find your a. So my x is going to be negative 3, my y is going to be 6. So 6 equals a negative 3 plus 4 double negative here, squared plus 3. Whoops. So simplify a little bit. A 1 squared plus 3. That came out weird. Plus 3. Remember, so in here, the 1 squared goes first. Remember, you power before you multiply. So it's 6 equals, well, 1 times a, so just a plus 3. Subtract the division on both sides. A equals 3. So my equation is going to be, I go back here, and now you only want to plug in for h, k, and a. You always want to leave y and x alone when you do the formal equation. So it's going to be a is 3, x plus 4 because of double negative, plus 3. And that's my equation. So we do the same thing on this one. I have my h and k already. All I gotta do is have my h is 5 and my k is 4. I gotta find out what a is. So what we're gonna do is plug in this other point here. It's x, this other point, which is when we count x and y. We're gonna use that to find my a. So 1 equals a, 6 minus 5 squared plus 4. Just like before, I get 1 squared plus 4. So you gotta do this first. So you equals a plus 4. Subtract 4 from both sides. So a equals negative 3 this time. So now you have everything you need because this is now negative 3. You can rewrite it. So I'm going to leave x and y alone. So it'll be negative 3 x minus 5 squared plus 4. By the way, a good way to check, make sure answer makes sense. This is a negative 3, right? It should be opening down. Look at my graph, opening down. Over here it's a positive 3, a, so it should be opening up. My graph is opening up. Next one, write each in vertex form and then graph the function. So we got to write in vertex form, we got to graph it. So remember, I don't care how you want to write in vertex form, quadratic, complete the square if you want, or just find the vertex. So let's find the vertex. X on the vertex, that's all messy. X on the vertex is negative b over 2a. So negative negative 4 over 2 times 2. So 4 over 4, which equals 1. So that's my x and my vertex. To find the y, you just plug it in. So 2 times 1 squared minus 4 times 1 minus 3. So that's 1. 1 times 2 is 2 minus 4 minus 3. It's me negative 5. So my vertex is 1, negative 5. So if I was going to rewrite it in vertex form, it would be y equals, I'll select the whole thing, that'll be right in vertex form. Right, so my a is that right there, so that's 2. My h is 1, and my k is negative 5. So get y equals 2, x minus 1 squared minus 5. Now they want me to graph the function, so the easiest way to do is find your vertex, 1, negative 5, so 1, negative 5. Or if I want the y-intercept, it's right there, negative 3. And you just kind of try to match these graphs. There we go. If I wanted axis symmetry, x equals 1, the first thing I found, you can do that if you want. So now it's the next one. Right, so same idea. Let's find the vertex, we open the vertex form. I keep on doing that. Let's find the vertex, h and k. So the way you do that is find x equals negative b over 2a. Remember my a here is negative 1, b is negative 4, c is negative 1. So -4 over 2 times -2. So I get 4 over -4 or -1. So that's my x, my vertex. You want to find the y, just plug it in. Y equals -1 squared minus 4 times -1 minus 1. So that's 1. So -1 plus 4 minus 1. Y equals 2. So my vertex is going to be -1 and 2. My a from up there is -1. So I can write my equation. I'm just going to write it this time. -1, x minus -1 squared plus 2. That gets, if I write that a little nicer, -1 x plus 1 squared plus 2. So that's in vertex form. They want me to graph it. Go to your vertex. -1 and 2 is right here. Remember, if you want the y-intercept, it's always the guy by itself, -1. So I know it's opening down. Well, it has to negative. So it's going to go like this. And then you kind of want to match it this way. Not my best graph, but hopefully the idea passed through. Next, we have a little application problem. So ball is thrown upward. The equation gives the height h of the object at any time t. And the equation gives a height h of an object at any time is this. I think they're supposed to say any time t. So t is time, h is height. Is a key thing here. So that's our equation. How high is the ball when it's first thrown? Separate equation solved algebraically. So when it's first thrown, that means time is 0. Anytime it's first happening, time is 0. So it's got to plug in 0. So it's like the y-intercept. Just plug in 0 and that all goes away and you just get 16. So 16, whatever units we're talking about. Right there. Where's the max height of the ball? Well, remember the way you find the max, this graph is going like this. I know that because it's a negative x squared. So how do you find the max? It's just the vertex. That's all it is. We just got to find the vertex like we've been doing. So how do we find the vertex? X equals negative b over 2a. Now over here it's a little tricky because it's backwards, right? A is always the thing next to your x squared. So in this case it'll be negative 16 actually. B is always the linear term, so 32. And C is the constant, 16. Right, so it's a little backwards, but it works the same. So we plug her in, so plug this stuff in, negative 32. 2 times a, which is negative 16. And I get negative 32 over negative 32, which is 1. So x is 1, my vertex. How do you find the y? You plug it in. I guess in this case it wouldn't be x, it would be t and h, but same concept. So plug it in, 16 plus 32 times 1 minus 16 times 1 squared. So I get 16 plus 32 minus 16. Well, those are going to cancel. So I just get 32. So my vertex is 1 and 32. Now the question though was, what's the max height? Now if you remember how you find max and min, it's actually always a y value. If you have a graph like this is 1 and 32. The height's the y value. So 32, I guess is feet, but it doesn't say, is the height. What's the 1 about? That's what time it takes for the ball to hit the ground. That's not the question. That's the time it takes to get to the max. Time to get to min or max. In this case, the max. It took 1 second to get to the max, which is 32. But what time does the ball hit the ground? So the ground means the height is 0. So you gotta set the height equal to 0. So 0 equals 16. Let me rearrange this. 0 equals negative 16t squared plus 32t plus 16. I just rearranged it. So hit the ground when its h's height is 0. So how do I solve it? Like solve anything else, factor, quadratic formula, whatever you want to do. I notice they're all divisible by 16, so I'm gonna do that first. Let's divide everything by 16, make our life easy. So I get 0 equals negative t squared plus 2 plus 1. So I get that. I don't like having a negative t, as you guys know me, so I'm gonna flip it over. I'm gonna get t squared minus 2t minus 1 equals 0. And then I gotta solve this. Oh, that is not factorable, is it? Yes, it is. No, it's not. It's not factorable. So I'm gonna do a quadratic formula. A equals 1, B is negative 2. Good old quadratic formula always works. C equals 1, negative 1. I mean, I could do complete the square, but that also works. X equals negative negative 2 plus or minus b squared, so negative 2 squared, minus 4 times a times c, all over 2 times a. So over here I get 4 plus 4, 2 plus or minus. So I get, oh, it's getting messy. 2 plus or minus radical 8 over 2. Radical 8 is 2 rad 2. So I'd actually just get, if I divide it 2 by 2, I get 1 plus rad 2. 1 plus or minus rad 2. And actually, I think one of those is negative. Rad 2 is bigger than 1, so I can't have a negative answer. So if I get this and this, rad 2 is like 1 point something, so this is actually negative. It makes no sense. Sorry about that. My actual answer should just only be this guy. It makes more sense to do in a calculator, which I don't have right now. I would use a calculator because it is an application problem, but that's the idea. What is the ball's height after 30 seconds? Was it possible to explain the answer? So that just means plug in 3 for time. So we had this. I mean, it's actually h. What I can put in y for? Equals, what was it? Negative 16 3 squared plus 32 times 3 plus 16. So what is this? 9. 9 times 16. That's 90 plus 54. So 144 negative. Plus 32 times 3, so that's 96 plus 16. This is doing a negative answer. The ball can't be negative. Best question answer is that the ball hit the ground before 3 seconds. Right, so if I had a graph, it's probably like this. Here's like 3, so that's why it's a negative answer. You must hit the ground beforehand. Especially after using calculator with point max, min, and all that stuff. Well, I don't have a calculator with me, so I was just going to label my maximum, which we got 1 to 32. Right there. And then I know it hits the ground before 3, so it looks kind of like this. And that's pretty much the worksheet.